Good evening, everybody. Now let us start our today's class. So today we will discuss about Laurents expansion theorem and some problems. So Laurents expansion theorem. Laurents expansion theorem. I will only tell you the statement, then some problem. Let C1, C2 denotes respectively. Let C1 and C2 denotes respectively two concentric circles, two concentric circles. What are these two circles? This is Z minus Z naught is equal to R1 and Z minus Z naught modulus is equal to R2. Okay. With R1 less than R2. With R1 is less than R2. Let f of Z be analytic. Let f of Z be analytic. F of Z be analytic in a region containing the circular annulus containing the circular annulus. This is R1 less than Z minus Z naught modulus less than R2. Okay. In this annular region, the f of Z function is analytic. Okay. Then, so if these two conditions are given, that means C1, C2 denotes respectively two concentric circles. Like if I will draw its figure, it will like this. So this is the center Z0. Z minus Z0 equal to R1 means this is a circle whose center is Z0 and radius is R1. Okay. So let the center be Z0 and this is the circle whose radius is R1. So this is the first circle. Z minus Z0 modulus equal to R1. Okay. Let's come to the second circle. Its center is Z0 and radius is R2. It is saying this is a concentric circle. Concentric means common center. That means both have the center Z0. Okay. So the second circle has center Z0 and radius R2. So center Z0 and the radius be R2. Okay. So this distance is R2. With R1 less than R2 and f of Z be analytic in a region containing the circular annulus, this one. So what is this region? Z minus Z0 is lying between R1 to R2. That means this is the region. I'll use this third color. Different color. So this is my circular annulus. Okay. This is the circular annulus. This is the circular annulus. Z minus Z0 modulus lies between R1 to R2. Then what we will do? These are the given things. Then what the Lorentz series expansion says, then the f of z can be represented as, then f of z can be represented as a convergent series as a series of positive and negative powers, convergent series of positive and negative powers of z minus z naught given by f of z is equal to, this is summation of n from 1 to infinity, this is bn divided by z minus z naught to the power n plus summation of n from 0 to infinity, this is an whole into z minus z naught to the power n. Okay, so if these two conditions are satisfied, then f of z can be represented as a convergent series of positive and negative powers of z minus z naught. Here the first term says these are the negative powers of z minus z naught, and this second summation says all the positive powers of z minus z naught, positive and zero powers. Okay, and what is here an and bn? So here we can write where bn is equal to, this is 1 by 2 pi I integration over C1. C1 means the first circle. Okay, what do you mean by C1? C1 means this is the circle, this one, z minus z naught, which is equal to R1. And similarly, what is your C2? C2 is the second circle, this is z minus z naught modulus, which is here R2. Okay, so then this is the integration over C1 f of j whole divided by, this is j minus z naught to the power minus n plus 1 dj, and your an is, this is 1 by 2 pi I integration over C2 f of j dj whole divided by, this is j minus z naught to the power n plus 1. So this is the an and bn, and this is the Maclaurin series expansion. And you may note that in Taylor series expansion, where the expansion takes place like at this z naught, the function f of z is analytic, but here f of z is not analytic at z naught. That means you can say Lorentz series expansion Lorentz series expansion takes as a power of z minus z naught, where z naught, where f of z is not analytic at z naught, where f of z, where f of z is not analytic at z naught. Okay, in Lorentz series, if the Lorentz series takes place above this point z naught, then, or you can say f of z is not analytic at z naught. Okay, but in Taylor series it is something different. If f of z is analytic above z naught, then you are taking z naught as a center of that power series. But here, if f of z is not analytic at z naught, then you can take z naught as the center of that power series in this Lorentz expansion case. Okay, this is the statement. Now we will go to problems, and I am not going to prove this expansion theorem. So next page we will do some problems. So let the first problem be, find the Lorentz series expansion. Find the Lorentz series expansion. Lorentz series expansion of f of z, which is your z square e to the power 1 by z. about z is equal to 0. So about this center means all the powers are in z minus 0 form, or you can say all the powers are in z form. That means you can say all the positive and negative powers of z only. Okay. So what is my f of z? So our f of z is, this is z square e to the power 1 by z. So you can write this, all the powers will be in form of z to the power something, z to the power positive power, z to the power negative power, like this. So z square is okay. Then e to the power 1 by z means, the series expansion of e to the power 1 by z. So I can write this is 1 plus 1 by z plus 1 by z square 1 by z whole cube, like this. If I will multiply this z square, I will get this is z square, then this is z to the power 1, then this is 1, then this is 1 by z, then this is 1 by z whole square, or 1 by z square, whatever it may be. Sorry. Uh, there, this is 1 by z, this is 1 by 2 factorial into this one, 1 by 3 factorial into this one, like this. So first term, second term, third term, there is 1 by 2 factorial, and here is 1 by 3 factorial, here you will get 1 by 4 factorial, because the expansion of e to the power z is 1 plus z by 1 factorial plus z square by 2 factorial plus z cube by 3 factorial plus dot dot dot. So this is the series expansion of f of z, and here you are getting all the powers are, like this is positive power of z, this is positive power of z, this is just z power is 0, and here z power is minus 1, here z power is minus 2, like this. So all these things are the power positive and negative powers of z. This is z minus 0. So this is the series expansion of this f of z above z is equal to 0. Okay. So if I go to another problem, find the Laurents series expansion. Find the Laurents series expansion. Laurents series expansion for, this is z divided by z plus 1 whole into z plus 2 about z equal to minus 2. About z is equal to minus 2. So z is equal to minus 2 means this is z minus minus 2, which will be z plus 2. So all the powers will be in this form, z plus 2. That means all the positive and negative powers of z plus 2. So now we can proceed. So here f of z is, this is your z divided by, this is z plus 1 whole into z plus 2. So if you will apply partial by parts, then you may write this one is your 1 by z plus 1 plus 2 by z plus 2 by using by parts, or you can say the partial fraction by using by parts. So this is your task, you will do it. So if this thing you are getting, so after making this by parts, I have to get z plus 2, because I have to make all these things as a power series or as a power of z plus 2. So how I will get z plus 2? So here z plus 1 is here, so I need z plus 2, so I will write this one as, this is z plus 2 minus 1, so it will be z plus 1, and second one is as it is, because z plus 2 is there, so 2 divided by z plus 2. So for the first one I can write, because I need z plus 1, sorry, z plus 2, so minus 1 whole divided by, I can take minus 1 common here. So if I take minus 1 common, then there will be 1 minus z plus 2. Okay. And the second term is as it is. 2 divided by z plus 2. So then what I will write, so minus 1 can cancel out, then this is 1 divided by, or you can say this is 1, and whatever the denominator is, this is 1 minus z plus 2 to the power minus 1, then plus 2 divided by z plus 2, and this one can be written as, this is the series expansion we already know. What is your 1 divided by 1 minus x, this is your 1 plus x square plus x cube plus dot dot dot, where mod x is less than 1. Okay, so I will use that formula. So this will be 1 plus, this is z plus 2, then z plus 2 whole square, z plus 2 whole cube, like this, then plus 2 divided by z plus 2. So if I will write it in the ascending order of z plus 2, then first I will write this is 2 divided by z plus 2 plus 1 plus z plus 2, then plus z plus 2 whole square, then z plus 2 whole cube, like this. And when I will use this series expansion, when z plus 2 modulus is less than 1. So this is the region of convergence. So this is the answer. All these things are the powers of z plus 2. Here z power of z plus 2 is minus 1. Here power of z plus 2 is 1, sorry 0. First one is minus 1, then this is 0, then this is 1, 2. Okay, so that's why I will say this is the Taylor series, sorry, Lorentz series expansion about z is equal to minus 2. So in Lorentz series expansion, the powers of z minus minus 2, which is your z plus 2, are a negative and positive and 0. Okay, so this is your answer. So now comes to another problem. Expand f of z, which is equal to z divided by, this is z minus 1 whole into z minus 2. Okay, in Lorentz series, expand this one in Lorentz series. In Lorentz series, valid for, so there are 5 pairs. First one, which one is valid for mod z less than 1, and in second one, which is valid for 1 less than mod z less than 2. Third one, which is valid for mod z greater than 2, and in fourth one, which is valid for mod z minus 1 greater than 1, and the last one, which is valid for 0 less than z minus 2 modulus less than 1. So all the all uh, all possible types of problems are available in this problem. So whatever you will get in your exam, these are like these things, mod z less than 1, or like this type of problem. So in this single problem, we will solve all possible types of problems which you can get for any Lorentz series expansion. So now I will solve it. So first I will write what is your f of z. So your f of z is z divided by, this is z minus 1 whole into z minus 2. So since this is in product form, I will use the partial by parts, so that this term will be separated. Then I will write, this is if you will use your by parts, this will be 1 divided by z minus 1 plus 2 divided by 2 minus z by partial fraction. Okay, so by using this partial fraction, first I will use the partial fraction on this thing, then I will get this one. Okay, so after partial fraction, then my problem is I have to use or I have to solve it by I have to expand it by Lorentz series expansion, which is valued for mod z less than 1. So it is valued for mod z less than 1. So that means all the powers should be in z form. Okay, all the powers will be all the positive and negative powers of z only. So that means z to the power positive, z to the power negative, z to the power 0. So how I will write this one? And as since you will just say here is a constant 1, that means here you will get z by mod 1, which is your mod z. This is less than 1, and here there is a constant 2. So you will get this thing. Since mod z is less than 1, so mod z by 2. So this is obviously less than mod z by 1. So mod z by 1 is less than 1. So you can say mod z by 2 is also less than 1. So all these things you will get. Since mod z is less than 1, so mod z by 2 is also satisfying this valued region. Okay, so whatever I will make the expansion here, all things will be the powers of z and z by 2. Because since mod z is less than 1, mod z by 2 is less than 1. So I will use that things. So here my f of z is 1 by z minus 1 plus 2 by 2 minus z. So, so I want these things z and z by 2. So I will take minus 1 common here. So it will be minus 1 divided by 1 minus z. Similarly, to get z by 2, I will take 2 common here, so that it will be 1 divided by z minus 2. Now we can proceed. So this is minus 1 whole into 1 divided by 1 minus z. So its series expansion is 1 plus z square plus z cube plus dot dot dot. And similarly, this is 2 by 2 is 1. Then 1 divided by 1 minus z by 2. So its series expansion is 1 plus z by 2 plus z by 2 whole square plus z by 2 whole cube, like this. So this is the series expansion. So if you will again simplify one more term, then there is the constant is minus 1, here it is plus 1. So it will be 0. Then here it is minus z, and here it is z by 2. So z by 2 minus z, which is your minus z by 2. Again, here it is minus z square, and it is minus z square by 4. So you will get this is minus 3 by 4 z square. Similarly, minus z cube by 8. So minus 7 by 8 z cube. So like this you will get. So this is the answer, and this is valid because z by mod z is less than 1 and mod z by 2 is less than 1. So all these things are the powers of z. Okay, so now comes to the second one. So for the second one, the what is the region? The region says that 1 is less than 1 is less than mod z is less than 2. So what will be the region? So first you should find the region. Then after finding the region, or after finding the term where the power series will occur, then you will solve the problem comfortably. So here the first inequality says 1 is less than mod z. So if 1 is less than mod z, you can say here 1 by mod z. This thing is less than 1. So this thing you get already. Then the second inequality says mod z is less than 2. So this implies mod z by 2 is less than 1. So whatever the power series uh, you want to solve here, or what is the Lorentz power series you want to get, all these things will be the powers of 1 by z and z by 2. Okay, so whatever the problem is given to you, you have to make this problem in such a way that you will get the power series in this form, 1 by z and z by 2. So now comes to your f of z. So your f of z is 1 by z minus 1 plus 2 by 2 minus z. So how I will get 1 by z? So if I will take z common in the first term, it will be 1 minus 1 by z. Similarly, I have to get z by 2. So how I will get z by 2? So if I will take 2 common, then it will be 1 minus z by 2. Okay. So now I got 1 by z here and z by 2 here. So now you can proceed easily. So this will be 1 by z, and what is the series expansion of this one? This is 1 plus 1 by z plus 1 by z whole square, or 1 by z square, then 1 by z cube, like this, and then 2 by 2 can cancel out, then this is 1 whole into, this is 1 plus z by 2, z by 2 whole square, z by 2 whole cube, like this. So if we will multiply 1 by z here, then this will be 1 by z, 1 by z square, 1 by z cube, 1 by z4, like this. And for this one, this is 1 z by 2, z by 2 square, z by 2 whole cube, like this. So if I will write on a single or in a ascending order or ascending power of z, then first I will write this dot 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 dot, then this is 1 by z4, 1 by z cube, then 1 by z square, then 1 by z. Now all these things are completed, then write these things, then 1, then z by 2, z by 2 whole square, z by 2 whole cube, like this. So this is the answer. Okay. So whatever the valued region or whatever the question asking to you, then you have to go accordingly. Okay. So then the third bit saying, what is the region? The third bit saying is mod z greater than 2. Mod z is greater than 2. So I need to write if mod z is greater than 2, I can write this is 2 less than mod z, and I want to write on the right hand side less than 1. So what I will do such that I will get the right hand side is less than 1. So I will get this one, this is 2 by z, 2 by mod z, which will be less than 1. So in each and every case you have to do in such a way such that the right hand side will be less than 1. So if mod z is greater than 2 is given to you, so first I will write this one is 2 is less than mod z, then I will divide mod z on both the sides such that I will get 2 by mod z is less than 1. So right hand side is less than 1. Then after doing this thing, so since 2 by z is less than 1, so whatever the things I will uh, solve here, I want to write all these things will be the powers of 2 by z. Okay. So also since the question is the constant are 2 1 1, like your f of z is, this is 1 by z minus 1 plus 1 plus 2 divided by 2 minus z. Here you just notice that 2 is a constant is here, but 1 a constant also here. So if 2 by z is your less than 1, so you can say your 1 by z, which is obviously less than 2 by z, and your 2 by z is less than 1. So you can say your 1 by z is also less than 1. So all the powers will be in this form, 2 by z and 1 by z, because in this term you will get 2 by z, and in this term you will get 1 by z, and since 2 by z is less than 1, similarly 1 by z is also less than 1 by using these things. Okay. So all the powers will be in 2 by z and 1 by z form. Now you can proceed. So how I will get here 1 by z? So if I will take z common, then it will be 1 minus 1 by z. Similarly, this is 2, and how you will get 2 by z? So if I will take z as common or minus z as common, then you will write this is 1 minus 2 by z. See this thing, I will take minus z common, and you know your aim is to get 2 by z. So if I will take minus z common, then you will get this is 1 divided by, sorry, 1 minus 2 by z. So now this is your 1 by z whole into, what is 1 divided by 1 minus 1 by z series expansion, this is 1 plus 1 by z plus 1 by z square, 1 by z cube, like this. And then for this one, this is minus 2 by z whole into, this is 1 divided by 1 minus 2 by z series expansion, this will be so 1 plus 2 by z plus 2 by z whole square plus 2 by z whole cube plus dot dot dot. Then how I will rearrange it? So if I will multiply 1 by z, then what I will get? This will be 1 by z, 1 by z square, 1 by z cube plus dot dot dot, then minus 2 by z after this multiplication. 2 by z on this second bracket. So 2 by z minus 2 by z whole square minus 2 by z whole cube minus dot dot dot. So now you can rearrange it, or now after subtraction what will be? This is 1 by z, this is minus 2 by z. So this will be minus 1 by z. Again this is 1 by z square, this is minus 4 by z square. So this will be minus 3 by z square. Similarly, this is 1 by z cube, this is minus 8 by z cube. So you can write this is 7 by z cube. Similarly, this will be 15 by z4, and similarly you can proceed dot 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 like this. So this is your answer. Okay, so whatever the region is given to you, where the expansion is valid, so accordingly to that region you have to do the steps. And the important step is you have to draw this thing. If mod z is greater than 2, then 2 is less than mod z, then 2 by z is less than 1. So the right hand side is less than 1 we got. So one series expansion is about this 2 by z. And here since the constant 1 is 2 and 1 is 1, so for that thing you can write shift if since your 1 by z is less than 2 by z and your 2 by z is less than 1, so I can say your 1 by z is less than 1. So if this thing is also less than 1, so we can uh, get the series expansion about 1 by z and about this 2 by z. Now go to the next problem. And the next problem, what is the region there? So for the next problem, it is z minus 1 modulus is greater than 1. Z minus 1 modulus is greater than 1. So this one means this is 1 is less than z minus 1 modulus, because I want to write the right hand side should be less than 1. Okay, so this one I can write this one as 1 less than mod z minus 1. Okay, so this one can be written as 1 divided by 1 divided by z minus 1 modulus. This will be less than 1. So all the things or the power series is above this point, 1 by 1 minus z. So I have to expand the given problem in such a way that all powers will be in 1 divided by z minus 1 form. That means all the positive and negative powers of 1 divided by 1 divided by z minus 1. Okay, so by keeping this thing in your mind, you can proceed. Okay, so now my problem is your f of z, this is 1 by z minus 1 plus 2 by 2 minus z. So how I will get z 1 by z minus 1? So first I will I have to get 1 minus z. So here to get 1 minus z, I can take here minus common. So if I will take minus as common, so this will be minus 1 divided by 1 minus z, and here this is 2 minus z. So to get z minus 1, also here I will take a minus common first. So there will be minus, if I will take minus common, it will be z minus 2. So in the next step, I will write this is, first one is okay, minus 1 divided by 1 minus z. And in the second step, sorry, in the second term, this is z minus 2, I have to get z minus 1. So this is z minus 1 minus 1, which will be z minus 2. So now after getting, sorry, z minus 1, the first term was okay actually. This z minus 1 is already here. So I have to write whatever it is, because z minus 1 we need. This is 1 by z minus 1, this is 1 by z minus 1, and I am changing the second term only. So this is z minus 1 minus 1. So whatever I will write for this one, this is 1 by z minus 1 minus 2 times. So to get 1 by z minus 1, I will take z minus 1 common here. So what I will get, this is 1 minus 1 by z minus 1. Okay. So I will get this thing. So now you can use your series expansion, which is your 1 by z minus 1 minus 2 divided by z minus 1, and this is the 1 divided by 1 minus 1 by z minus 1. And you know this series expansion is valid if 1 by z minus 1 is less than 1. Whatever I am writing 1 divided by 1 minus x, this mod x should be less than 1, and this mod x is this one, 1 minus, sorry, 1 divided by z minus 1 modulus, because this is the region, you know. So what is the series expansion of this one? The first one is 1 by z minus 1, then minus 2 by z minus 1 whole into, what is the series expansion of this one? This is 1 plus 1 by z minus 1 plus 1 by z minus 1 whole square plus 1 by z minus 1 whole cube plus dot dot dot. So if I will, I can simplify one more line, and this is 1 by z minus 1, then this is multiply this one on this bracket. So this will be minus 2 by z minus 1 minus 2 by z minus 1 whole square minus 2 by z minus 1 whole cube minus 2 by z minus 1 whole 4 minus dot dot dot. So this is your answer. Similarly, what is the next bit? The next bit is the region is 0 less than z minus 2 modulus less than 1. Okay, so the right hand side is less than 1, it is so we have to expand the given problem in such a way that all the powers are of z minus 2, that is all the positive and negative powers are z minus 2. So my what is my problem? So my given problem is 1 divided by 1 minus z, 1 divided by, this is z minus 1 plus 2 divided by 2 minus z. So I want to get this thing, z minus 2. Okay, so I can do this thing here. So z plus 1 is here, so I can add this is z minus 2 plus 1. Similarly, this is if I will take minus common, it will be z minus 2. So to get this z minus 2, what I will write? So I can write this is 1 divided by 1 plus, this is z minus 2. Then minus 2 divided by z minus 2. Then what is the series expansion of this one? We know this is 1 divided by 1 plus x is here. 1 minus x plus x square minus x cube plus x4 minus dot dot dot, where mod x is less than 1. And here mod x is z minus 2, and it is saying already z minus 2 is less than 1. That's why I am proceeding in this way. So what I will write, this is 1 minus z minus 2 plus z minus 2 whole square minus z minus 2 whole cube plus dot 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 minus 2 divided by z minus 2. So, if I will rearrange it in the ascending order of z minus 2, so first I will add this one. This is minus 2 divided by z minus 2, then plus 1 minus z. This is plus 1 minus of z minus 2 plus z minus 2 whole square minus z minus 2 whole cube plus z. So this is your answer. So these are the all possible problems associated with this Laurents series expansion. Okay. So today only this much. Thank you.